Now that we have all the devices registered within SuperCloud Composer and part of the HPC AI rack, we're going to start phase 2 of the CDI lifecycle management. So let's go ahead and launch the CDI module within SuperCloud Composer. We'll go ahead and drag this down to get it out of the way here. And we'll go into our tree view and basically see switches that have been registered already within the rack configuration of SuperCloud Composer. The switch that of interest to us is the 10.2.6.79 system. You can see here that this is related to what we call a pre-provisioned fabric. So no topologies or configurations have been loaded on the switch, but the switch has the intelligence based on fabric services that's running on the switch, where we have now discovered two particular hosts that have been connected to the PCIe switch fabric based on a 4x4 bifurcation of lanes, both 5.9 system and 5.13. Both of them are showing up with the actual ports in which they're connected to with the 4x4 bifurcation of 16 lanes. The next step of this process is to be able to load a top-of-rack switch provisioning or configuration of our PCIe switch fabric. So to do so, we're going to go ahead and click on the plus sign here to start the creation of our PCIe topology. You'll see from the quadrant that's provided here, it steps you through a very nice wizard to go through each one of the bubbles that are basically presented within provisioning of the actual switch itself. You'll see here that what's presented to you is various different topologies that you can load within SuperCloud Composer. So by this time, you've already cabled up your cable plant, interconnected your switches together. If you have a multi-switch configuration, in this particular example, we're using a standalone configuration. So you'd have your APA cabled up into the PCIe switch itself. You also have your management interfaces of your APA also connected into an Ethernet switch technology, and also your hosts that are connected into your PCIe switch as well. So you'll also see here within the topologies, we do compliance and governance or checking to make sure valid topologies can be actually uploaded to the switch configuration. So the check mark indicates they are correct topologies to be loaded. The yellow triangles indicate caution that these are not supported topologies within how many hosts and JBOGs that are connected based on the number of ports within your PCIe switch fabric. So we're going to go ahead and choose the IS 2x4X1. You'll see here provides a very nice view to show you how things are connected within the switch itself. So we'll go ahead and give it a topology name. We're going to call it Accelerator Pool. And when we go ahead and choose that option, this particular option is in support of NTB and GDR. So we'll go ahead and say next here. And at that point, you can see we only have one switch in the configuration, which is our primary switch. If you had two switches, you'd have a primary and subordinate switch, which both of them are tied together, and the primary switch provides the fabrics service where we make Redfish calls in to be able to compose resources from the APA itself. You'll also notice that there's a blue box around the switch to indicate that we're focused specifically on the switch itself. You'll see that blue box move as we continue through the wizard configuration. All right, so we'll say next here because all of it is ready to go. So the next piece of this is to provide hosts that are configured within our composition phase, or be able to deploy operating systems to those hosts. So we'll give it an APA4. I'm just making up these numbers here itself. I'm sorry, UB4. I'm just making these numbers up. You can call them anything you want there, and then UB40. Okay, once you do that, both of them can be deployed for operating systems. If you've already deployed an operating system where it loads a one-click operation for the host drivers for CentOS, are embedded in the actual push of the deployment of the OS. You can basically say no there if you like. So we're going to go ahead and deploy operating systems for each one of the hosts. So we'll go ahead and say next here. And then the next phase is, notice, it now drops down and focuses on the APAs, the JBOG or the accelerator pooling appliance. So we're going to have two particular drawers here. One drawer is going to be focused on GPUs. The other drawer is going to be focused on FPGAs. So let's give them names: pooled GPU, and then also pooled FPGA. Okay, and once we give them their host names, we'll say next. And then here is the resource box to indicate to you what you have configured. You'll notice that each one of the check marks now indicate that health is in good standing. So we check the health of the server to validate that it is truly in good standing. If it were to be an unhealthy situation, then we would not allow you to proceed with the composition of the topology or the loading of the top of rack switch. We'll say submit here, and at that point it'll submit it as a task. We can then move over into the log information and basically watch this start to bake. You can see here that it's in progress. It's starting successfully to allocate and assemble and push out operating systems to those two hosts that are connected to the PCIe switch.